So, haloarenes preparation. Did you revise your haloalkane preparation? So, tell me, Tuhina, what happened in Schwartz reaction?
Sir, it's a halogen exchange reaction,
Hmm.
and so its reaction is used to prepare fluorine, like
Chlorine.
fluoride compounds.
Hmm.
Metallic fluorides are employed as reagents, and when they react with other halogens like
Hmm.
bromine, iodine, or chlorine, uh, they will
Hmm.
form haloalkanes. I mean, haloalkanes as in
Fluoro.
fluoride ones.
Okay. Next, Sarah, what is Finkelstein reaction? Sarah, what is Finkelstein reaction?
Sir, I did not revise it.
Okay, so Sarah, when you know ki your chemistry need to work on, so read more. When I am doing one particular chapter, give more time to this. Okay. Next, Barinder, what is Finkelstein reaction? Barinder, what is the Finkelstein reaction? Barinder, are you there? So we are talking about how we can make haloarenes. One thing from hydrocarbon, even haloalkane you can make from hydrocarbon. But what is the specialty when we talk about the haloalkane formation from hydrocarbon, Sania?
Yes, sir.
So what is the specialty when you make haloalkane from the hydrocarbon?
Sir, in some cases, we cannot directly make haloalkanes from hydrocarbons because of the reactivity of the product.
Yes, but if you elaborate more, due to the free radical mechanism, multiple products are formed, and that's why yield will be poor. Okay. When we talk about hydrocarbon, in hydrocarbon example, if you take CH3, and in this case, if you take benzene ring like this, so this is hydrocarbon. You have two possibility. Example, so if it react with the iron and it is dark and it react with the halogen. I told you example of the school, canteen, and this school canteen and child. Example, here this is canteen, this is school, X2 is the child student, and FE is parent. If parent go with the child will directly go to the school. If parents are not going with the child, then there is high chance child can go to the canteen instead of the school. Got it? So if you take this, you have same benzene ring, and ortho and para product will be stable. CS3, CH. Got it? So, what is the difference? Here you have halogen in the canteen. Here you have halogen in the school. Got the difference, guys?
Sir, can you repeat?
Here, if you are taking hydrocarbon, benzene ring is like school, CS3 is like canteen, parents are like FE, and X2 is the child. If
Yes, sir.
parents are going with the child, then child will directly go to the school. School means benzene ring. Here you can see child is going to the benzene ring. But if you don't have parents, like child don't have parents, then there is high chance that child will directly go to the canteen instead of school.
Yes, sir.
Okay. So in this case, you will have electrophilic substitution reaction. Pratikya, what is the meaning of this electrophilic substitution reaction?
No, याद नहीं है इसका.
Electrophilic substitution reaction means a reaction in which you know your X halogen will substitute something else. And here halogen is acting like electrophile. And what is the reason? If you take X2, what will happen? Bond of this X2 will break. If it break, it will convert into halogen positive and halogen negative. Correct? So what will happen? Hydrogen will be removed from the benzene ring or CS3. So you will remove HX. You will remove HX. Same here, you will remove HX. So negative halogen will go with the hydrogen and it will be removed as halogen acid. But main point is your one of the halogen is acting like electrophile. Understood? And both the X what you have seen in this situation are electrophile. Your electrophile substitute the hydrogen. Anybody have doubt?
So can you explain it once more?
Yes, Sania.
So can you explain it once again?
Which one?
So the electrophilic substitution one.
Yes. So electrophile, electron loving means itself have the positive charge. Correct? Itself will have positive charge. Now in this case, halogen should have positive charge. This positive charge halogen will attack some hydrogen. Hydrogen will be substituted and halogen will added there. Correct? Here you are having CH3 in the reactant. In the product you have CH2, one hydrogen removed and halogen added. Understood? So electrophile is substituting your hydrogen. Okay, just give me 1 minute. Somebody texted. बरिंदर तुम्हें आवाज नहीं आ रही थी? Anybody have doubt in this, guys? Electrophilic substitution reaction from
No, sir.
hydrocarbon. We are making haloarenes. Method is different. In our NCRT, we have mainly this product. This is given in NCRT, not second one. But NEET asked this question, and that's why we are doing it. Remember, you already know though this thing. The electron donating group is ortho or para-directing. While if you compare electron withdrawing group, it will be meta directing. And here we know CS3 is a electron donating group. So it will be ortho and para directing. Para will be more stable. Correct? Para will be more stable. Both will be there. Got it? Any doubt? Anybody have doubt? So if you guys, anybody have doubt? Am I audible?
Yes, sir,
Not
you're audible, no doubt.
Huh. So if no doubt, example, you have two compound. One is ortho and second is para. 1, 2, 3, 4, 5, 6. Same. 1, 2, 3, 4, 5, 6. So you have two benzene ring. In both the situation, you have CS3 and X. CS3 and X. Tell me guys, how to differentiate them? Because you know in reality we can't see them. How to differentiate? These two compounds are differentiated based on the melting point. Okay, so these two compounds differentiated based on melting point. How? If you see para have more melting point compared to the ortho. And how do we know? Due to close packing. Due to close packing. So you can see here para will have more melting point. And based on that, you can differentiate the ortho and para are different. How? They have different melting point. So through this, we got to know that using hydrocarbon, we can make haloarene. Second, so using second is aniline. If you use aniline, you can still make this, and this is extremely important. Send me a reaction. Send Mears reaction. Sania, what happened in Sand Mears reaction?
sir.
What is the name of this compound? Parinder,
Aniline.
aniline. NaNO2 HCl react at very low temperature 0 to 5 degrees Celsius. Same thing is written as 273 to 278 Kelvin. So this is aniline. You can make haloarenes using the aniline. Yes, Tanya, what will be the product in this case? What is the name of this compound, Tanya?
Sir, diazonium salt.
Benzene diazonium salt.
Yes, sir.
If you have this benzene diazonium salt in the form of the halide, you can use it for the multiple purpose. We already did this using the from this chapter amine. Example, if you have this, let me quickly revise your diazonium salt from the amine. If you have this, Pratigya, what will be the different product if you are using diazonium salt?
CO2Cl2
Hmm.
and CO2Br2, copper
Hmm.
powder,
Hmm.
and शायद फ्लोरोबेंजीन में कुछ था, याद नहीं है।
If you use Cu2X2, this X2 can be chlorine or bromine, and this is known as the cuprous form plus 1 copper. This is Sandmeyer reaction, and in this case, what will happen? You will make halogen, and N2 will come out. This reaction is known as actual Sandmeyer reaction. This is actual Sandmeyer reaction. Next, Tara, if you take copper powder and make benzene ring, what will be the reaction name and what will be the product? Is this Gattermann reaction? Gattermann reaction,
Yes,
and
sir.
product will be same depend upon which halogen acid you are using. Next, how many of you are there? 4 or 5? Did I address everyone? 5. Pratigya, Varinder, Sania, Sara. Okay. Tuhina, if you want to make iodine, what you should use in this situation?
Uh, I don't remember, sir.
Simply Ki, nothing else. Why? Highly active.
Sir, NaI?
Ki simply because
No,
here
can
it
we
can easily
use
release
sodium iodide?
sodium iodide.
Can we
Sodium
use it instead of
iodide,
potassium?
the reason is you can use, but reaction will take time. But in Ki, because down the group ion size is increasing, so it will easily release I negative ion.
Hmm.
Got it?
Okay.
Hmm.
Yes, sir.
Next, Barinder, if you use HbF4 and heat this, what will be the product? Fluorobenzene. Ar means benzene. Fluorobenzene. Next, Pratigya, if you take H2O, what will be the product?
Yeah,
Pratigya, if you
English
take hmm,
safe.
phenol, OH, phenol. Next, Tanya, if you use either H3PO2 or you take C2H5OH, what will be the product? Sania.
Sir, will it be phenol?
No, benzene. It will be benzene. Hydrogen. Why? Because your this H3PO2 will convert into H3PO3. Your C2H5OH will convert into CH3CHO. So removal of hydrogen from the reagent and addition to the benzene ring, because these compound undergo oxidation, so it will cause reduction of the diazonium salt. Barinder, if you take HbF4 and then you take copper cyanide, was it copper cyanide, copper and NaNO2, what will be your product? Barinder. Nitrobenzene. Nitrobenzene. Tuhina, if it react with the phenol, what will be the product?
Mm, I'm not sure, sir. Will it be diphenyl? I don't know.
No. It will be diazonium salt.
Yes, sir.
Correct? It will be, I will take it like this. 1, 2, 3, 4, 5, 6. One benzene ring, nitrogen, double bond nitrogen. Second benzene ring, and then OH. This will, because phenol is acid, so it will react in the presence of base and it will be orange color. Okay, this is known as benzene diazonium. Parahydroxy, parahydroxy, azobenzene. Azo means nitrogen, nitrogen double bond. Sarah, if you react with the aniline, what will be the product? Sarah, any doubt? These are known as coupling reaction or azodite test. In both the situation, there will be coupling reaction or azodite test. So noted this also. This is coupling reaction. Why coupling reaction? Because it join two benzene ring. Azodite, because you have azo N2 double bond. Also, because it have color, orange color. This will be yellow color. So this is colorful. That's why azo dye test. Got it? Same for the aniline. Any doubt, guys? So that's why it's important to compare the Sandmeyer reaction, because in both the situation you are making it from the diazonium salt. In case of Sandmeyer reaction, you use the copper in the metal form, but here you are using copper in the powder form. That is the biggest difference. Where you get better yield, Sania? Out of Sandmeyer and Gatterman, because in both case reactant is same, product is same, reagent is also very close to each other. Where you will get better product,
So Gatterman
better yield?
reaction.
Sandmeyer. Here you will get better yield.
Sir, but
आपने क्या
why, sir?
पूछा फिर से बताइए.
प्रतिज्ञा, मैंने पूछा कि आउट ऑफ सैंडमियर एंड गटरमैन रिएक्शन, गटरमैन रिएक्शन लुक सिंपल कि कॉपर सॉल्ट विल रिएक्ट, सॉरी, कॉपर पाउडर विल रिएक्ट and it will form halobenzene, correct? But in reality, what happen in Sandmeyer reaction, you will see, because you have copper ion, so this copper ion help in the removal of nitrogen gas and halogen easily. In case of copper powder, it is just like acting like surface, nothing else. Got it?
Yes, sir.
So this is given in your um, amine chapter. I just gave you quick revision of the amine chapter. A very big topic, diazotization, diazonium salt. last topic of the chapter, right? So we revise every single thing, whatever you need over there. S3PO2 is important, this is important, this is important. Coupling reaction azodite test is important, everything. But for in this chapter, only send me a reaction is given. Any doubt, guys? And with this, haloarene's preparation is done. Now, physical property. Physical property is easy. More or less, physical property of all the organic compound is same. Not only class 12, even in class 11. If you have hydrocarbon, more or less, physical property is same. You should know what is the impact of the electron withdrawing group, electron donating group. So I'll take just 5 minutes to 5-10 minutes to quickly revise this physical property. And example, if you take boiling point method remains same throughout the organic chemistry. Okay. First, most of the alkyl halide are colorless compound when they are pure, in the pure form. But you will see if you take RBr, bromoalkane, or iodoalkane, in this case, they will develop color. How is that possible, Pratigya? Development of color in case of haloalkane, especially iodine and bromine.
DD transition.
Because DD transition, you don't have
Yeah.
even d block element because of the large size. They can easily get exposed from the light. And if you see smell, usually they have sweet smell. Okay, this is very very important. Melting point and boiling point, especially boiling point. Everywhere this is important. Melting point and boiling point. So if you see this melting point and boiling point, what happen if mass is more, then boiling point will be also high. If mass is more, then boiling point will be high. What is the reason why boiling point is high? Because of the more mass. Answer is, in this case, van der Waals force will increase, and van der Waals force is because of the mass only. And second, because there is electronegativity difference, that's why dipole-dipole interaction. That's why dipole-dipole interaction. Okay. If you see the boiling point, then example, if you compare Tuhina, Ri, Rbr, RCl, RF, which one will be more?
RI, sir. RI
Sarah,
will
is
be.
this Sarah, is this correct?
So based on what, sir?
Boiling point.
It's- It should be the other way, I think.
It is other way. Sania, is this correct?
Yes, sir,
Mm.
it is correct.
When are you sure this is correct?
Yes, sir, because mass is increasing, right?
Hmm.
So,
Mm. I am feeling bad and guilty. I was trying to be like in the right answer. I will ask everyone, and you will think, oh, I might be wrong.
no, sir.
So what iodine is like
Heavy mass.
better living group.
Yes, it is, Sarah, but the point is the mass. More mass, more boiling point.
Okay, okay, sir.
Yeah. Second, in the same thing, ki if you increase branching, surface area will increase and boiling point will decrease. In the simplest way, if you increase branching, boiling point will decrease. But when boiling point is, you are considering boiling point in this case, but only when mass is almost same mass. I will give you example. Example, if you have this CH3, CH2, CH2, CH2 iodine. In this case, CH3, C, CH3, CH3, I. In both case, mass is exactly same. But in second case, you have more branching. What will happen to the boiling point, Marinder? If you consider boiling point out of these two, one or two. Marinder, one. Why? Because straight chain have more boiling point. Pratigya, if you take ortho, meta, para, what will be the difference in the boiling point? If you take this is ortho, this one is meta, this one is para. Right? So you have three benzene ring. In first, you have any halogen X, 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 and X, X, ortho, meta, para, where you will have more boiling point.
think para
Para is maximum, then
meta ortho.
para, meta, ortho. Sania, do you agree with this?
Sir, I think ortho is like,
Maximum.
yes, sir.
This Sara,
Sir, ortho.
ortho. Tuhina,
So para.
para.
Sir,
Yes. Pratigya.
I think ortho, para, and meta.
Okay. Marinder, Marinder, are you there? Is she there? First one, 442. Answer is all three of them have almost same boiling point because same mass, same branching. When you compare boiling point, it will be same because same branching, same mass.
Sure, but the thing is, won't para make it more like symmetric and the lattice structure will be more,
That
uniform?
will affect the melting point.
Okay.
So if you take melting point, then para will be greater than ortho and then meta. And region symmetry, more symmetry. So if you have more symmetry, better packing, and better packing means more boiling melting point. More symmetry, better packing, and high melting point. Anybody have doubt?
सर बॉन्ड एंगल कुछ मैटर नहीं करेगा क्या?
नहीं. So related to your boiling point, you have density. So density increase when mass increase and density decrease when volume increase. So what happen when your mass increase, your density will also increase. If mass increase, you know your uh, boiling point increase. So more density, more mass, more boiling point. Correct? If your branching increase, then density will decrease. and surface volume will increase. Understood? So it is related like almost like the boiling point. Almost. More mass, more density. More volume, less density in case of branching.
Sir,
Yes, Pratigya.
the Sania message to me कि he will come within the 5 minutes.
She will come within the 5 minutes. Okay. Let's do last topic of this class, which is the solubility. She's not there in the group right now. Solubility. Tuhina, what happened in the solubility?
Sure, I'm not sure.
So if you see haloalkane, they are slightly soluble in water, not much.
So the lower ones are more soluble, I believe.
Yes, in general, lower organic compound are more soluble because less hydrocarbon part. More hydrocarbon, less solubility.
Yes, sir.
If you have more hydrocarbon part, more carbon chain, then solubility will reduce in general in water. In water, decrease. Okay. So reason here, you need to require a lot of energy to break the bond. Less energy is released. More energy required to break bond, to break bond, then energy release. So that's why solubility will be less. Done. So with this, we are done with the physical property. We quickly revised diazonium salt, which was extremely important from the amine as well, and general preparation of the haloarenes. Now we can move to the major part of this chapter, the most important part of the chapter, chemical reaction. At any cost, in next class, we will finish this chemical reaction and this chapter will be done.
सर लास्ट वाला पॉइंटर दिखाएंगे.
बिल्कुल बिल्कुल. Any doubt,
हो
guys?
गया सर.
Anybody? Huh. Example, if you take this question, example C2H5 iodine and C2H5 fluorine. If you consider density, which compound will have more density? Sarah.
Uh, Sir, first one, C2H5I.
Yes, because more mass, more density. Barinder, if you take um, CHCl3, CH2Cl2, and CCl4, which one will have more density? Barinder. Pratigya.
CCl4,
CCl4 maximum, then
CHCl3, then CHCl, CH2Cl2.
anybody have doubt? More mass. In third, you have 4 chlorine. In first, you have 3 chlorine. In second, you have 2 chlorine based on the chlorine because mass. Got it? Next. Mm, Sania came.
Yes, sir.
Okay, Sanya, so tell me this question. CS3, CS2, CS2, Cl, and here you have CS3, C, CS3, CS3, CH2, Cl. Where you will have more mass?
सर दोनों का मास तो सेम ही होगा।
तो boiling point.
सर बॉइलिंग पॉइंट पहले वाले का ज्यादा होगा।
Yes, because less branching. Hello. Good evening, ma'am. कहाँ से मैम? क्रेडिट भी पर्सनल लोन? यस मैम। लोन अप्रूवल हुआ है? मैम मुझे तो 20 लाख का लोन चाहिए था। नहीं मैम, इतना तो कम है तो काम नहीं चलेगा। ओके। डन गाइस। Anybody have doubt? So boiling point question are important. And with this, we are done with the preparation, physical property. Only one topic is left, chemical property. Okay. So next class you will have at, I will take little bit late, 8 o'clock. Little bit late, 8 o'clock. What you have to do, I will send PDF. 10 question from your solid, okay, and 20 question from your haloalkane halogens. Total 30 question in next 3 hours.
तो
Okay,
सॉलिड से कितने क्वेश्चन करना है?
10.
हाँ सर,
Yes, प्रतिज्ञा.
तब मुझे थोड़ा टाइम लगेगा, मैं लेक्चर नहीं देख रही हूँ सॉरी का।
हाँ, तब तक लेक्चर कंप्लीट कर लो, थोड़ा जल्दी हो जाए क्योंकि
हाँ सर,
लेक्चर में
मैंने
भी
भी नहीं देखा है सॉलिड का लेक्चर। सर मैं वो देख के फिर कर।
मैं थोड़ा
हाँ
बाकी था केमिस्ट्री का कुछ पिछले
हाँ,
तो मैं देख के कंप्लीट करके आपको दो मतलब भेज दूंगी सर।
सर बाकी 20 क्वेश्चन किसके करने हैं?
haloalkane halogens, and send me your notes and watch recording. Don't simply go through the notes. 3 1 2 क्वेश्चन सेंड कर देंगे बरिंदर. Don't just go through the notes क्योंकि